All right, your anti-set today is a little bit of a throwback to first semester. Um, I want you to find the normal vector and the tangent plane to this paraboloid right here, x squared plus y squared. At x comma y equals 1 comma 3. Um, you should try it, your intuition. It was like ages ago, but if you want to just watch the video so you can see how to do it, that is fine. So if you want to try it, pause. All right, here we go. Answer's coming. So the first thing that I want you to do, or that you got to do, is you got to find the z value. So that's 1 squared plus 3 squared, which gives me 10. Then I find my partials. Partial x is 2x of that thing. Partial y is 2y. And I evaluate them at 1 comma 3. So I get 2 and 6. From there, I know that the tangent plane contains these two vectors, 1, 0, 2. That's because this is the change in y if I move x by 1, right? So I'm going to have a ratio of 1 in the x to 2 in the y. And same thing here, except for the 1 goes with the y because this is a f sub y. So got 1, 0, 2, and 0, 1, 6. Oh, I should mention, well, one, the answer is that, okay? Down here. Either of those would be good. Some of you liked doing this with like a linearization or like a what do we call it? Like maybe like a differential or something like that. F sub x dx plus f sub y dy plus f sub, uh, something like that, right? But this one takes us through a path that is important to where we're going today. Anyway, I cross u and v to find the normal vector. My n is u cross v, which this should be familiar. I hat, j hat, k hat across the top. 1, 0, 2, that is this vector. 0, 1, 6, that is this vector. Remember, I hat, don't forget your minus on the middle component, right? The checkerboard plus minus thing on a cross product. Or on a 3D determinant, I guess is what I should say. Anyway, I get this, which that, once you simplify, comes down to -2, -6, 1. This is the normal vector. What I want to point out is that, look, let me zoom out a hair. Um, this is my f sub x value there. This is my f sub y value there. Some of you, when we were doing this, noticed, like back first semester, oh, this was always going to be the negative of that. And this was always going to be the negative of that, and I was always going to get a 1 here, right? So what I want you to notice is that this is negative f sub x, comma, negative f sub y, comma, 1, right? And that came up in the end of the last lecture and is going to be what the beginning of the first of this lecture that you're going to watch today is all about, right? So that right there is important, and it's not a coincidence that these guys show up like that with that 1. So that's the normal vector. And then my tangent plane is, I take advantage of the dot product. You go back and look at your notes from ages ago, but n dotted with a vector within it, within the plane, is 0. That makes it so that n is perpendicular. Hopefully this is ringing some bells. Excuse me. But the n is my -2, -6, 1. So I get -2, -6, 1 multiplied by x minus x naught is my 1, y naught is my 3, and z naught is my 10, right? So I get -2 times x minus 1, -6 times y minus 3, that's the y naught, plus 1, that's this one, times z minus 10, that's the z naught, equals 0. You can get this formula using a differential that I mentioned above. And I think some of you actually preferred that, just fine. But I do want you to notice that this is always going to be true. You could even work it out with differentials, which gives me this thing here. So hopefully that rings some bells and you remember how to do that and follow along in the instructions that I give you in the Google Doc.